Hello, everyone! Chapter 1, Learning Target 1. We're excited. This is Miss Oshier.
And Miss LaHart.
And here we go. So, you are going to be using 3 to 4 exponent rules at a time.
Dun, dun, dun.
So, let's quickly remember those rules one by one.
Beautiful. All right. The basics. All right. You know, you got your base and you got your exponent.
Boom.
Yep.
Okay.
We're going to talk about them.
So, product rule. Now, these are all also in your introductory packet, but we're putting them all together here.
Mm-hmm.
Okay.
And it doesn't hurt to go over them. Here we go.
So, product rule. When you are multiplying two bases that are the same, so in this case x and x, you are going to add the exponents.
Oh boy, let me get quotient rule. When you divide, you subtract from the top to the bottom a minus b, and then technically the the quotient goes into the numerator.
Technically, yes.
Yes. And then you fix it if you need to.
And then, power rule. So when you have a base being raised to a power that is then raised to another power, you're multiplying those powers.
Power to a power.
Boom, boom, boom.
Negative rule. If you see a negative exponent, in order to change it, just move it. So for this one, it's technically in the numerator, so you move it to the denominator and make the exponent positive.
Because remember, this is technically over 1 right now, so you just essentially flip it. So if it's in the denominator, poof, it turns it positive in the numerator.
Mm-hmm. And you could put that over 1, but...
Mm-hmm.
Okay. Power of a product. You can distribute. So you can take x times y raised to a, and that is also equivalent to x to the a, y to the a.
Mm-hmm. Power of a quotient, same rule applies. If you have a fraction of sorts, a division problem, being raised to an exponent, that means both parts of the quotient are being raised to the same exponent.
0 exponent. I love these ones.
This one's the easy one.
Anything raised to the 0 is?
1.
1.
Every time.
Okay.
Exponent of 1 means it stays the same.
Okay, we have to notice this because if you have an x, you have to know that the exponent is 1.
That's important. This is not an exponent of 0. There's an imaginary 1 right there.
You can't just ignore it.
We don't usually write it. It's just there.
Right.
Okay. So
here we go.
Time for some examples.
Here we go. Take a deep breath.
Okay. Whew. Remember, you guys are big kids, so we're doing 3 to 4 at a time. So I'm going to think of it kind of like an order of operations. I see these parentheses over here and this exponent hanging out, so I'm going to attack the right side of this first. So I'm going to use this exponent on every single part here because this entire thing is being raised to the 4th power. So using power to a power, I have 2 to the 4th because technically there's a 1 there. C to the 1 times 4, A to the 2 times 4. So now we have 16, C to the 4th, A to the 8th. The biggest mistake people will make is they'll do 2 times 4 because they'll be thinking power to a power is multiply. 2 to the 4th is what you're doing here. It is 16, not 8. Be careful.
Mm-hmm. So then you put it back, and now you're sitting at multiplication. So you're going to multiply. 2 times 16 is 32, and then you're going to add your exponent. B, there's nothing else to add, so you bring it down. C, 0 plus 4, 4. And then, 8, you just bring it on down.
Bring it on down.
There you go.
Okay, simplify.
Ooh.
So I'm going to get rid of that power again. So I'm going to do 2 to the 2nd. M to the negative 4 is going to be multiply because it's power to a power. And again, I'm just doing that power to a power rule, multiplying all of my exponents. Clean that up. I have 4, M to the negative 8th, N to the 6th, P to the 4th. We don't like negative exponents. We want only positive exponents because we're positive people.
Mm-hmm.
Okay.
Now we're at quotient, so let's do the division, which means we subtract our exponents. Be careful because we're dealing with negatives. So M will go negative 8 minus a negative 3. So technically that's going to become a double negative, which is a positive. So that's going to turn into negative 5. 6 had nothing to divide. 4 minus 3 will give you 1. So the only thing that we have to fix is that M to the negative 5 right there. So we're going to move it to the denominator and stick a fork in us. We're done.
Boom. Okay, here we go again. Ooh, this whole thing is to the negative 2. Now, there's a few different ways you could handle this. You could just, because that's a negative 2, you could just flip the whole thing.
Mm-hmm.
Okay, you can multiply everything by negative 2. There's a lot of different ways to handle this, so it just depends on how you choose to. So let's just deal with the numerator first.
I like to simplify first.
Okay, so we have 2 times 2 is 4. So we're actually ignoring this exponent right now if you did not catch on to that. 2 times 2 is 4. We're just going to clean this up. B to the 1, B to the 0, B to the 4th. That's where these numbers are coming from. I hope you're with us now. And then all the A's, we're just multiplying. So all of those exponents are being added because we're using the product rule. Excuse me. There we go. Okay. Denominator's already cleaned up, so now that looks a lot less scary.
Now, I'm pretty sure I did this simplification. I can't really remember. Oh, no, I flipped it. So you can flip the entire fraction if you have a negative exponent. So that's what we did.
So the 2 stays, but because it was negative, we just flipped everything. And now that negative is gone.
And then I'm pretty sure we squared everything.
So 2 squared is 4, b squared to the second is b to the fourth, yada, 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 yada.
And now simplify.
We got to clean it up a little bit. I have a 4 minus a 10, and I see this negative here, so there's a few things I still need to deal with. And if I deal with them all at once, the 16, the negative 16 is going to pop up to the numerator. 4 minus 10 is negative 6, which means that that negative 6 is going to pop down to the denominator. When we start doing multiple steps like this, I just look at it like this. I know that's going to be the difference of 10 and 4. 10 is the bigger number, so I know that my positive exponent is going to end up at the bottom. There's lots of different ways to start dealing with this once you deal with multiple steps.
Yep. No way is the wrong way.
No
sometimes.
way.
As long as you're
right.
As long as you keep the rules right. Okay, now the harder ones are the ones where you got fractions as exponents.
I'm so scared. Don't be afraid of fractions.
Don't be afraid of fractions. Now, I'm not sure what I start.
Oh, you know, sometimes this just happens. So hi, there's a black screen there. It's going to be fine.
It'll come back.
It's just going to come back in a second. But what we want you to realize is that's the same rules, even though there's fractions, so don't be afraid of fractions. We're still going to do the exact same thing we were doing. And look, there's the answer. We cheated.
Okay, so what did we do first on this one? Well, it looks like I multiplied through.
So negative times a negative is a positive. 3 halves times 1/3, those 3's cancel. You have negative 1/2. If what I just said scares you, you have a calculator that can assist you, etc. We're just doing the power to a power. 0 times anything is 0, yada, yada, yada.
All right, then we have division on the left, so we do subtraction. Looks like we did. M doesn't need anything to cancel, so that goes over. Technically,
negative 1/2 minus a negative 9/4 is actually plus 9/4, so it's going to give you 7/4. Because this would be in halves, 4 halves.
Yep. 4 over 2.
Oh, 4/4. Excuse me. No. What did I just say? 2/4. There we go.
2/4.
2/4. Negative 2/4 plus 9/4 when we subtract. There it is. Okay. And you're just going through and subtracting.
Very carefully.
This guy just goes away. Why does this guy just go away?
Anything to the 0 is 1.
Woo!
There we go.
I like those because you just cross them out.
Well, that was out of order.
Okay. Now, that was just showing the other 2 steps. So this was, we did the numerator, and that's what you ended up with.
Yep.
Okay. So there is your answer. All pretty at the end. These get messy. You're going to want some room. You might need a scrap sheet of paper next to you. You're going to be okay. We hope you have a fantastic day, and we will see you in class.